So as we wrap up this semester, we're going to talk about diffraction. So what is diffraction? Well, it's really the same thing as interference. I think of diffraction as self-interference. So you can imagine that you've got a single slit. Now, when we talk about interference, we remember we had two slits. So we had two slits, and we had said that light traveling here, we have a bright spot in the center because light would travel the same distance, from both slits. Light traveling up to here somewhere travels this extra distance. The extra distance, the extra distance traveled right here is going to be the delta x is d sine theta, and so that's our extra distance right there. And so if d sine theta was equal to a lambda, get constructive interference, or if it's m lambda, then so if that's m lambda or m plus 1/2 lambda, this is constructive interference. This right here is destructive interference. Well, what's this diffraction stuff? So imagine we just have a single opening. Your book calls the width of the opening A. I don't know why they don't call it D, but they just call it A. And so what happens is now you imagine here that once again we get a bright spot in the middle. But the thing is that as light, remember we talked about the Huygens principle, so each little segment of this opening is its own source for light. So that means light from here can spread off that way, and up here can spread that way. And so now there's still a difference in path between the top and the bottom. And so what happens is, if you imagine this thing is two slits, each slit is with a over 2, so between this slit and that slit is a distance, the d equals a over 2, then we're in the same sort of mentality here. And so that is that if this d sine theta equals m lambda, we get constructive interference. And if d sine theta equals m plus 1/2 lambda, we get destructive interference. But d is a over 2. So that means that a over 2 equals m a over 2 sine theta equals m lambda. That's going to be constructive. So a over 2 sine theta equals m plus 1/2 lambda is going to be destructive. Okay, so let's look at the destructive interference for just a second. Okay, so we have this single slit. It's going to have a bright spot here, and the bright spot is going to expand outwards until you get to the first destructive interference. So the question is, what's the angle to that first destructive interference? That tells you how wide that central bright spot is. Well, the very first one would be if m equals 0. So a over 2 sine theta equals 0, 1 plus 1/2 lambda. Or in other words, a sine theta equals lambda. So this is going to be your first minimum. Well, the second minimum is going to be a sine theta equals 2 lambda. So that's going to be your second minimum. So we can now say that a sine theta equals m lambda, where m is an integer. So this is going to be where we find the minima. Okay. And so now notice this looks like the same equation for maxima for the double slit, except that we had a D instead of an A. The A is the width of the slit. And so you notice that the narrower the slit, then the farther apart the minima are going to be. And so the more spread out the light is going to be as it passes through. Okay. So this is our introduction to diffraction. Okay. So now what we need to do is figure out a way of applying this. So that's going to be our next step.